Functions. The definition of a function is something that we will explore through the whole chapter. Make sure this definition gets into your notes to self. So in 2.1, we just start establishing, well, what is a function? So a function in words, how you would describe it, is a pairing of two sets of numbers so that each number in the first set corresponds to exactly one number in the second set. So the equation is y equals 3x plus 1. That is an example of a function. Okay, well, how is that a pairing of two sets of numbers, you're wondering? So my x values are going to be one set of numbers, and my y values are going to be another set of numbers. Okay, so if I choose values for x, I will find their pair in the y values. Well, how does that work? Well, for x, I can choose anything I want. So because I can choose anything I want, I'm going to choose something easy, like 0. If I choose 0 for x, I want to know what y value goes with that 0 that would make this function or equation true. So this is how it works. Y equals 3 times, now instead of x, I'm going to use 0, plus 1. Y equals, well, 3 times 0 is 0, plus 1, so y equals 1. So 0, 1 is my first pairing that satisfies that equation. Okay, my second pairing, let's choose something like 1. Another easy solution, another easy number to work with. So I do it again. Y equals 3 times 1 plus 1. Instead of x, I used a 1. 3 times 1 is 3, plus 1 is 4. So y equals 4. So the combination here is 1, 4. Okay, so this pair satisfies this equation. This pair satisfies this equation. Okay, I hope that's making sense. Okay, so now I've got 3 more spots. What do I want to choose? Well, somebody might ask, well, can I put in something for y and get something for x? And the answer is yes, you can. So what if I chose y equals 7? So I'd have 7 equals 3x plus 1. Okay, well now I have to solve for x, so I subtract 1 on both sides, and I get 6 equals 3x, and I divide by 3, and I divide by 3, x equals 2. So 2 comma 7. Well, I kind of knew it was going to work out like that, but I could have chosen another value, and it would have given me perhaps a fraction, but that's still okay. So now let's choose a big number, and I'm going to choose a big number for x. Let's choose 100. So if I put 100 in for x, I get y equals 3 times 100 plus 1. Y equals 300 plus 1. Y equals 301. Okay, another pairing. Great. Now I'm going to choose a different kind of number. How about a negative? Negative 3. So y equals 3 times negative 3 plus 1. This gives me negative 9 plus 1. This gives me negative 8. Okay, so now I filled up my chart. Well, how many more are there? Like, how far could my chart go? How many more different solutions or pairings would make this equation or function true? Think about it. A lot. In fact, infinite. I could keep coming up with different x values that I could plug in and make a y value for. I could use fractions, I could use decimals, I could use negatives, I could use positives, I could use huge numbers, I could use, excuse me, very small numbers. So there are infinite possibilities. I could use values for y and figure out values for x. I could come up with infinite possibilities that would satisfy this equation. So that's overwhelming. I can't possibly list all of these. So what you should do is you should actually come up with a way to show it, a different way to show it. How about a picture on a graph? Well, look at these different pairings. Oh, and before I show you the picture, let's go back to the definition. A pairing of two sets of numbers, okay? My one set of numbers is my x, my second set is my y, and I'm pairing them up so that they satisfy this equation. Then this says, so that each number in the first set corresponds to exactly one number in the second set. So that means that 0 only has one number that it works with in order to satisfy that equation. Okay? We'll talk about scenarios where it is not a function, but not today. All right? So now all of these are different pairings, or otherwise known as ordered pairs, because they're in a specific order. So remember from last chapter you had x comma y, 0 comma 1, 1 comma 4, 2 comma 7, 100 comma 301, -3 comma -8. Interesting. Well, let's try plotting them. So 0, 1, remember you do your x first and your y second. 1, 4, 1, 2, 3, 4. 2, 7, 2, 1, 2, 3, 4, 5, 6, 7. 100 comma 301. Well, 100 I don't have 100, and 301 I don't have that, so I have to skip that one. -3, -8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I've plotted all the points that I can point. If I had gotten a fractional point, you could plot it, but it's kind of hard to do because you have to estimate. Okay. So now, if you notice, these line up. Oh, I'm trying to use this tool here. Let's see how this works. If I use this tool, I would get not this, not this. Let's try again. No. So I'll use my pen to do it, which is not going to be efficient, but if I notice, it actually would line these up in a perfectly straight line, which is not shown by my line, so please use a ruler on your homework when you're doing this, and I'll figure out my tool for the next video. Okay, so they line up in a straight line. 100 comma 301 is actually going to be way, 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 way up on my line, but it still will be on that line. So this line represents the function y equals 3x plus 1. It's also represented by this table that has all of the points that I have listed, and it's also represented by this picture. It is best represented by the picture and the equation because this encompasses all of the solutions, whereas this is just, the table is just a snapshot of things that would work. Does that make sense? Okay, now you can also have a picture of a graph and try to come up with a function that would work for it too. So now this is a function, it's a straight line, and now I'm going to figure out, okay, what is my set of points or my pairings that would work here? Well, let's figure out what points this crosses. I'm not going to choose a point that falls in between two blue lines. I'm looking for blue intersection points, like right here, or right here, or right here, or right here. Ooh, my, I see a bunch of points. Now, I'm not going to choose this one here because you see how it's not perfectly aligned. Okay, so let's start filling in our graph. What are my points here? X is 0, Y is 2. So 0, 2. All right, what's this one? 2, X is 2. What's Y? 3. Okay, what is my X on this one? 1, 2, 3, 4. And this is 4. Okay, how about this one? It's -2 on my X. And on my Y, it's 1. And this one here is -1, 2, 3, 4. 0. Okay, and there are more. And in fact, there are infinite. But these are points you could list, but I just don't know exactly what they are because they are in between the blue lines. So I choose the ones that are easier to see. So now I have a table that represents the function. I have a picture that represents the function. Now all I need is the equation to represent the function. Okay, you're going to learn how to do this better as you go through the chapter. I'm going to show you how to do it now, but I'm going to revisit this again. Okay, so it's like that old game you used to play, maybe or maybe not. Here's the guy. You put it into his head and he spits it out. Okay, I put a 0 into his head, he thinks about it and he spits out a 2. I put a 2 into his head, he puts it in his head, he spits out a 3. I put a 4 into his head, and he goes into his head, and he spits out a 4. I put a -2 into his head, and he spits out a 1. I put a -4 into his head, and he spits out a 0. These are my sets of my x values. These are my sets of my y values. If I put an x into his head, what am I going to spit out? Well, what am I doing? I'm actually taking half of x, and then I'm adding 2. So y equals half of x plus 2. And again, like I said, we're going to keep visiting through this. What happens here, if I take 0 and I put it in here, I'd have half of 0 is 0 plus 2 is 2. Does that work? Yes. If I put a 2 in here, I have half of 2, which is 1, plus 2 is 3. Does that work? Yes. If I put a 4 in, half of 4 is 2, plus 2 is 4. 4, 4. So each of these will work. Okay? Again, that is actually not in this lesson when you go through the problems, but it will be in future lessons. Okay? Good luck.